Hello everyone, welcome back to Phosphology 2021. We will be starting now the evening sessions with Harris, who will be presenting a look beyond the edge with visual field. If you want to present yourself, Harris, or if no, I can proceed to the video.
Thank you very much, Jose. Yeah, please go ahead and play my video. It's pre-recorded, and I hope to take questions after the video. So yeah, thank you.
Okay, perfect. So let's start.
Introduction to visual field. I'm glad you're still with us, Buenos Aires. I hope to be online now to take your questions. Thank you. Buenos Dias, Argentina. I'm coming to you from southeastern Australia, home to the Yuan people. My name is Harris and I'm a 30-year IT professional. I'm delighted to be able to present here at Phos4G 2021, and believe it or not, it's actually 3 a.m. in Australia right now, so my talk is pre-recorded, but I hope to be online after to take your questions. The climate's going to need all the help it can get, Geo people. I'm going to briefly introduce an application I've developed, give a quick demonstration, and end with some ways that you can get involved. But first, I have a question for you. Is there an elephant in the room?
I mean, right where you're watching this, is there an elephant with you? You might have seen a lot of elephants in this conference so far, and I'm sure those elephants have really great features. I don't dispute that for 1 second, but that's not what I'm talking about. I mean, 77% of you are probably looking at it right now. I mean, something that supports that, what I'm talking about. That is, of course, WebSQL. Did you know that most browsers have an inbuilt relational database that supports SQL syntax? And it's embedded with zero installation. It's fast to load and index. It's scalable and can handle big data. And it's supported in 77% of the browsers. Why aren't we using SQL? Because of this lack of standard support. But that was 10 years ago. So why aren't we using SQL? The web ecosystem has continued to evolve since 2010. We now have CORS, HTTP headers, and the availability of large open relational data sets, amongst other things. So now I'd like to introduce Visual Field. It was developed, the core of it, in 2019, makes heavy use of WebSQL. It's essentially a versatile single HTML file, 23,000 lines of code, works with delimited data sets. You can load and manipulate and visualize your data. There's no HTML or JavaScript programming, and it's an open source application built on other open source components. So you can ingest data sets or files or URL, import export CSV, import export workflow metadata, import export your database dumps so you can transfer it to another instance, export SQL dumps, and import media. Visual Field is intended to be loaded in a versatile way. You can use it as an online application, offline, as a standalone file, or as a progressive web application. It's got a series of workflows, sequences to support workflow automation, and you can manipulate your data sets using SQL, custom functions, direct editable content, and you can save your workflows as metadata. Visual Field is built on a whole spectrum of open source JavaScript and CSS libraries. So there's a wide variety of visualizations available. Table visualizations are scalable for big data. Chart visualizations are scalable up to 10,000 data points for pie, line, bar and scattered charts, up to 4 series. Maps are scalable up to 120,000 features, 6 custom or leaflet styles. Heat maps are scalable for big data sets. Network visualizations support both logical and physical, scalable with an explore and walk the network mode. You can perform shortest path searches, and you can save and reload your network graphs. Slideshows are scalable for media, and all visualizations can be incorporated into sequence workflows and combined with drill down URL links. I'm going to give a demonstration of Visual Field, and I'm just going to do that by going to visualfield.org, and I'm going to run Visual Field online here. But before I do that, I'm just going to say that the example I'm going to show today is not going to be a perfect example, because I will lead into the next part of my talk about that. If you want to see a more seamless example, just come and look at some of the examples on the website here. So we're just going to load Visual Field there online. Now, as part of saying that, I don't mean any disrespect to the publishers or the custodians of these data sets, but the data sets I'm going to use here, coming from datas.gov.ar, and the first example I want to look at is this data set here, which I'm not exactly sure what it represents because my Spanish is no good, but I'm just going to right-click on this CSV link here. I'm going to copy that link address, go back to Visual Field, and we'll see if we can import that as URLs just by pasting the URL there, and I will put in a table name. I'll just call that table 1 and just go ahead and try to import that. And you notice we get this error here. Now, this error is typically indicative that that data set doesn't have CORS HTTP headers. But we'll just work with this in a manual way. We can continue with this. So we'll just go ahead and download that CSV, and we'll just go back to Visual Field and just take that CSV that we manually downloaded instead of a URL. We've got it here, and we'll just upload it there. And there's our data set there. We've got our provinces, and notice this field here, we've got some sort of percentage value here. So the first thing we'll do is just see if we can show that as a chart visualization. So we'll go to chart visualization, select the table that we've just created, which is that table there. We'll call this our chart as a description, and for the title we'll just put our chart, and for the x-axis column we'll put the province name, and we'll order by the province name, and the chart type we'll select a bar chart with a fill, and for the y column we'll select that percentage value there. We'll just leave it like that. We'll just save that and go ahead and run that. And there's our chart there with our provinces and that percentage value shown there. But what we really want to do is show these provinces in some sort of map. So what I have found on datas.gov.ar, there's another data set here where we have some province centroids as CSVs. So I'm just going to download this data set. Just click on there, and there it's downloaded. Go back to Visual Field, and we'll just import that provinces data set. Take a look at it. So here we have some sort of centroid latitude and centroid longitude and the province name. So now I'm going to combine those two data sets by way of creating a view. Now, to assist me not having to type this, I've prepared some earlier. So I'm just going to run this, and let's take a look at this. Here I'm going to create a view which is a simple cross join between those two data sets, and I'm also going to manually assemble by string concatenation a WKT geometry. Now, I could have used a custom function, but I'll just manually assemble that. String concatenation. I'll select another field as tooltip, and there it's a simple cross join between those two data sets. So then I'm going to go to map visualization, and we'll select that view that we've just created, map view, and we'll call this our map, and for the title we'll just call this our map, and the geometry column will be that centroid WKT, and the tooltip I will select as that column value as tooltip, and we'll just save that and go ahead and run that. So there's our simple map that we've got, and if I click on those centroids there, you get the pop-up. If you hover over there, you get the tooltip of the field that we've just set up. But now let's look at getting some styling set up on this map. So to do the styling, there's two things I'm going to do. I'll go back to SQL, and I'll just drop that view to start with. Just drop that, and I'm going to recreate that view with a little bit more complexity to it. So in this case, I've got the WKT, the tooltip, but I'm also going to include a case expression where I'm going to translate that percentage value to some sort of HTML color. So then let's go back to our map visualization. And again, to save me time, I prepared one earlier. So I've got this one called Our Map 2. Now let's just have a look at this. Over here in the custom styling, I'm setting the fill color to a column value of PCT, which is that percentage that I just set up as part of the case expression. I've then got some other values here, radius hover of 10, fill opacity 0.9, weight of 0.5 to change the stroke color. So these custom styles are just leaflet path styles. So I've got that set up there. So let's just run that and have a look at that. So there's our map with a bit of styling on there. The fill color is based on the percentage value that we had before. And so that looks pretty good. But when we zoom into here, what has happened to Buenos Aires? We don't seem to have that on the map. So maybe there's something wrong with our join. So let's just go back and look at our tables. So we'll just browse the tables here and let's have a look at this first data set that we loaded by browsing that. So there's Buenos Aires there. And we notice the province ID, which is what I was joining on, has a value of 6. Okay, so let's take a look at our provinces. Let's just browse that table. So if I sort by name, there's Buenos Aires there, and we look at the ID, and in this case it's 06. So perhaps our two data sets aren't quite congruent. So let's go back to our SQL and we'll just go ahead and drop that view, and I've got a third view saved here. If I just take a look at that, here I'm going to do a bit of cleansing in that view. So I'm going to cast the join conditions to integers. So we'll do a bit of cleansing in our SQL. So the remaining part of the view is the same, but we've just done a bit of cleansing in our join condition there. So then let's go back to our map visualization and try running that again now. And so that looks a bit better. If we zoom in there, we can see we've got a Buenos Aires now. So I'm glad you're still with us, Buenos Aires. So that's the end of the demonstration. So who could use Visual Field? Well, teachers, students, data analysts, GIS analysts, web developers, report writers, data scientists, field workers, emergency workers, anyone really with even a bit of SQL knowledge is helpful. But please be patient. It takes a different way of looking at things. Some people have taken a look and they don't come back. So just be patient with some of the advanced topics like browsing of objects, sequences, custom functions, drill down and metadata. There's various built-in pages and tutorials to help out in this regard. So what can you do? For teachers, students, GIS analysts, data analysts, field workers, emergency workers, take a look, try it out, be patient. For web developers and report writers, explore, try to make sense of how the metadata is passed in the URL, try to bring your workflows to life in a web context. For authors of web libraries and frameworks, for example, charts and maps, get ready to make your framework scalable and responsive for big data in the browser. At the moment, Leaflet is scalable up to about 120,000 features. Chart.js is scalable up to about 10,000 rows. We need to get ready for larger data sets. For open data sets publishers and custodians, please provide your relational data sets as CSV. There's standards that exist for CSV, so please continue to provide that. Include your spatial data in CSV as WKT. If you're providing spatial data sets as CSV and some object or reference to a proprietary data format, you'd need to question really, is that an open data set? I'd encourage the use of WKT in your CSV data sets. Ensure your data sets are congruent and ensure that your data sets have HTTP course headers as part of your data sets. For publishers of web map tile images, please include coarse headers as on your tile images. That's so that tile images can be stored in an offline tile cache. For browser developers or those who have any input to web standards, can we either formalize
Shanahan, and I am the chief of the
another standards-based SQL engine in the browser? And can we have some rich functionality with that SQL engine, whether that's some sort of spatial functionality or whether it can have interoperability with JavaScript functions? Can we have a native CSV parser as well? So my message, really what I want to get across is I predict one of the next evolutions of the web ecosystem will be in part about big data in the browser. And my message is not so much about visual field itself, but really there's a need for relational big data storage in the browser. And then you can empower your end users, consumers of both yours and other data sets, and you can perform spatial analysis for those who may have nothing more than a low commodity phone and an unreliable internet connection.
And there you have it. That's my introduction to Visual Field. I'm glad you're still with us, Buenos Aires. I hope to be online now to take your questions. Thank you.
Well, that was an amazing talk. Thank you very much, Harris.
Yeah, thank you for playing that. There was a slight interruption, but that was very, very good. So thanks for
Yes,
that.
sorry about
I'm
that.
happy to take any questions now. So thank you.
Let's see. So far, there are no questions. So please, if you want to ask something, don't hesitate to post it in the questions tab. Meanwhile, do you want maybe a comment about your video or something?
Oh yeah, what I would say is that there's a lot of flux and dynamics going on in relation to Web SQL, and I'm not so much campaigning for that, but it's on the cusp of being deprecated from all browsers. There's a lot of changes happening, so I feel there's a real need for a relational data store in the browsers where the web ecosystem is currently heading. So if you find this useful, you need to get out there and campaign with the browser developers to keep this functionality or to have it replaced with some standards-based functionality to really go forward with this. Yeah, that would be a message I'd like to get out there.
Definitely. Well, we have a question. You mentioned the format should be CSV. Any thoughts about WebAssembly port of GDAL to support more formats?
Well, CSV is it's a ubiquitous format for consuming relational style data. So it lends itself very well to being imported into tables. I'm not sure how that comes into play with WebAssembly. That's a programming language where CSV is like just a plain delimited data sets, and there's a lot of CSV published in a lot of data providers these days. So yeah, it lends itself to being imported into relational data structures.
I see. Thank you. And well, so far we don't have any more questions. Let's wait for a minute or so. If not, we can call it here, if it's okay with you.
Okay, yeah. Thank you very much for the opportunity to present here at Impossible G. Thank you very much.
Thank you very much for your talk. Actually, sorry, we will be seeing you around in Phosphor then.
Yeah, thank you. Thanks,
Take
Jose.
care.
Yep, thank you.
And then we will be proceeding to set up the next talk. We already did before, so the next talk will be starting at past. So see you soon. Hello everyone. Hello everyone. Welcome to Phosphor-G 2021. This is the afternoon of Thursday in Huamahuaca zone. And next we will be having Ivan Sanchez,
We
who will be
have, yeah, I have a very technical or very academic sounding talk. If you want to say the name, Joshi.
yes, techniques for representing until GIS data in WebGL structures. That's a tongue twister, actually.
It's a mouthful, definitely. Yeah, but let's start. Let's put my slides on and let's go with it. So, hi everybody, I'm Ivan. I'm doing WebGL things. I want to say that this talk is going to be heavy on the computer science part of the GIS component. This is going to be hard to understand if you are more of a natural sciences person. Again, be advised, this has some hardcore computer science concepts thrown in. This is not the first time I do a talk like this. I realized, looking at my archives, that I did a similar one back in 2016, where I just explained what I learned from fumbling around and trying to make WebGL work. So if you have the time and curiosity, it's a good idea to look into video archives for the Phosphor-G in Bonn and watch it. Okay, so a bit of context. I have been doing leaflet maintenance for a while now, since I was kind of upgraded to a maintainer because I was doing some bug fixing in the core. And these days, this is my personal opinion. I want to remark it's a personal opinion. It's okay if you don't think like me. I'm pretty sure that the open layers folks think differently, but this is my personal opinion. Leaflet, I can understand it from start to end. I just can do HTML elements, work with them, mess them around. It's absolutely wonderful. But I'm kind of burnt out from it. There hasn't been any actual tangible support for maintaining Leaflet. Everybody wants to use it. Everybody thinks that it's awesome. Nobody really wants to work on the hard bugs that it's plaguing it's maybe a bit heavy word, but the code base, it's aging and not too well, and it needs some heavy work, and nobody really wants to do it. Now, Mapbox has the Mapbox GL2 library, but Mapbox has been losing a lot of flaws karma in 2021. They closed sourced Mapbox GL2. They have also some union busting rumors, which are not sounding too good, and they have lost a few points in my scorecard. Other than that, we have some other mapping libraries such as OpenLayer, Cesium, MapLibrGL, which all use WebGL, and they are absolutely fancy and they work fast. Unfortunately, I cannot make heads or tails of the architecture, and then I feel like an idiot because I'm supposed to know how web maps work, and I cannot, for the love of me, understand how OpenLayers of MapLibra work internally, not to talk about Cesium. So I have been trying for years to try and make a web map library using WebGL that I can understand at least, and failing miserably to do so for years on end. I have been learning more things as time has gone. This is the main takeaways I want to present today. OpenGL is not object-oriented programming. The GPU is a peripheral, and I can do some tricks to handle the problems derived from floating point arithmetic, the anti-meridian, and raster meshes. So part 1 of 5, this is not object-oriented programming. I said this already 2015, so I'm really still angry about this, really angry. Okay, in any programming language, or in any well-known programming language, the way you deal with data structures is pretty much the same. You create a data structure, and then you can just put a value in some particular position or particular point inside that data structure. This is all fine. And if I know one programming language, I will instantly understand any other programming languages that look similar. In this case, it's all the same, really. The only difference is that in JavaScript, the things are empty, and in C, Rust, the things have a explicit type. The whole concept is the same. And these are programming languages, which means they have a syntax, they have semantics. So they form actual language constructs that are there to be understood by people. Subject, verb, object, this I can understand. I know that the operation is doing something on the subject. That's it. This is like basic understanding of programming. It's kind of too obvious, but that's it. Now, when you are dealing with either OpenGL or WebGL, the API is so convoluted, in my opinion, that it goes the extra weird way to do something. Like, I want to create some place to store 5 numbers, and I want to set the second number 5. So I have to do all those things that have nothing to do with either the second. There's no number 5 and there's no number 2 in all that code, which is extra confusing because you have to assume the data type before you actually create the data structure, which is even C is better than this. So it gets me angry every time. So if we think of programming languages as languages, and I look at this specific sentence, what is the subject in that sentence? Because that's gl.buffer subdata. So I'm storing some subdata in a buffer of that context, but that buffer is an entity in itself. I have created a buffer just before with this thing, and I have stored it in this variable. So why am I not using that thing instead? Why I have to bind the buff and then say it's active and then do operations in that one? It just doesn't make any sense to do an operation in something that is completely unrelated. That breaks encapsulation. It's bad. It's not an object. People in OpenGL books and literature call a buffer a vertex buffer object with the O at the end. And I say, this is not an object. This does not follow any of the object-oriented programming guidelines or concepts. It's incredibly confusing. It's a syntactic sugar problem. It's not a hardware problem or a architecture problem. It's syntactic sugar. A compiler can take care of this. However, in my personal experience, every time I try to complain to the OpenGL people about this fact, with a proper academic discourse about lack of encapsulation in WebGL structures is kind of cumbersome, and I would like this to be other way, because this is the response I get: direct mode! Dude, you don't understand this because direct mode is good. And it's like, I don't even have the time and energy remaining to explain that this is not about direct mode, it's about syntactic sugar. This is how it feels when I'm talking to OpenGL people. It feels bad, and I think this is a roadblock in the way to understanding the whole technology. So in the end, I made a whole abstraction library to try and overcome these problems. I'm going to put a link there so you can see if you have the time and curiosity for it. So instead of having a buffer, which I just will do crazy things with binding the active or whatever, I can define a data structure which makes sense. I can understand this. This is a variable size data structure with in which every of the items is a 3-vector component. So I can store a 3-vector component in any position, which this has a proper syntax and a proper semantics. Okay. Part 205. Oh my God, have I eaten already 8 minutes? I am doing bad. The GPU is a peripheral. This has to do with how memory is handled by computers. Anybody with knowledge about computer science knows that there's a thing called memory hierarchy, because different types of memory technologies have different access times and throughput and capacities. Well, capacity is really a function of price, really, but you cannot have $1 million RAM chip everywhere. So this is how it usually goes. CPU registers are like maybe 10 to 20 numbers. So you can understand me. L1 and L2 cache it's a few thousand numbers. Then RAM, it's a few million or a few milliard. And then you have hard drives, which is as much as you can afford because it's kind of inexpensive. The interesting thing that I want to focus on is that accessing the different kind of memory have different times. This is the latency. I'm not talking about throughput. I'm talking about latency, which is the time to reach that part of hardware and then come back with the result. These are typical times. I like to put it here because I can see the magnitudes in a better way if I just align everything. There's jumps in the magnitude when you go from the CPU to outside of the CPU chip into the RAM, and then another very big jump when you go outside of the RAM and into actual permanent storage. This is important because we computer scientists know that if we're handling things in memory, it's really fast. Memory packs efficiently. There's something called the spatial cache neighborhoodness. I forgot the name, but it's when you are storing things next to each other in a data structure, it all hits cache, and you don't have to go to RAM. You hit L1 cache, and then everything is ejected together. So this saves time. You can even assume lower numbers for that. When you're doing the same-ish thing to permanent storage, you are opening a file and you're going to write 5 letters to it. Each of those write operations is going to take 20 milliseconds because this is blocking, or at least your program has to wait until the operation is finished, because that's how it usually works unless you are pulling some tricks. Even though I'm doing technically the same, which is storing 5 values in the data structure, the fact that one of those data structures relies directly on a different hardware technology has a direct impact on how much time you spend doing those same 5 operations. So, it's way better instead of putting 5 letters in 5 consecutive actions. It's way better to concatenate all those 5 letters in memory. And doing that concatenation will take some time and will take some time to write it in memory, but it's way faster because you only did one slow operation, which is the important thing when you're dealing with latency. You have to pack things and prepare for the bus transfer and stuff like that. The important thing here is that the GPU is a peripheral. It is connected to a bus in your motherboard. It has a higher latency than your RAM. So every time you are storing one value in the GPU memory, you have to go all the way and back, especially since we're using WebGL. WebGL has an extra constraint, which is you cannot do this asynchronously. You cannot queue this. Whenever you make a call, you have to wait for the call result. So this latency is real. So when dealing with WebGL specifically, when you're going to store some pieces of data in several positions, which, by the way, are not 0, 1, 2, 3, 5, it's 0, 4, 8, 12, 16, because each of those you have to know in advance that they are 4 bytes each. Fun. There's the possibility of typo just explodes. The one at the left is 5 times slower than the one at the right. Even if the one at the right involves doing more work in RAM, it will have only one problematic or one slow operation. In other words, if I'm using my fancy understandable library, instead of doing 6 operations to store 6 different 3-component vectors, I would like to do one store operation. So this will shave time. I think I'm not going to be able to show this. It's possible to do some timings in the browser with 2 of these different approaches. When I'm doing this approach, I'm going to do, which is the one from the, I don't have the coastline example open. I want the coastline example because I did this yesterday. So if I'm loading a big data file and then I'm adding all the symbols together, is way faster than if I would be adding the symbols one by one, because in this case, I will be calling this thing a lot of times, and each time I add something to the map, it will write into GPU memory, and that starts being slow. So it's important to cache and put together all the things you can in advance. Okay, well, I just showed this on the code editor, so I'm not going to mention anything except that map has several meanings when you're dealing with functional programming in GIS. By the way, I am very angry at the amount of meanings of the word layer. I hate that you can layer a layer of a layer in a layer of a layer. So yes, we're doing maps of maps. Why not? Floating point arithmetic. Okay, people who don't know about computers think that computers are magic and can do incredible math, and they can't. Computers do not understand equations. They do not understand calculus. They suck at that. You have to think them as calculators. If you don't get why 80,085 is a joke, good for you. I'm getting away with this. So please do think that every number that you put into a computer is a number that has to be shown in the LCD screen of an old calculator with a limited amount of digits. And if the number becomes too big or too small, you will start adding the scientific notation at the end. Like this means times 10 to the 9th power, for example. This is the very easy way to understand why numbers in computers are not always what you think they are. The floating point number thing means that whenever you have a point, you have to think, or you have to imagine that the point floats around the number. So you have a set amount of digits to work with, and then the point can go in and out, even away from the screen, which is when the scientific notation happens. Okay, the problem with this is, for example, you have a calculator with 4 digits on the screen, and you want to sum 9,999 plus 5, for example. The number does not fit on the screen. You have to drop something. So that drop something is going to mean that you are going to have like 1.0 times 10 to the 5th power, which is 10,000, and you have to drop a digit there because it will not fit in the screen. That's the point. What's the issue with this? That WebGL and OpenGL2, they are all technologies, and all the numbers that they use, you have to assume the worst case scenario, which is float 24, which is 16 bits of precision, which means 5 decimal digits. It sucks. It really sucks when you need to store big numbers because you start losing precision because you have to drop everything here. In JS specifically, I guess you know where this monolith comes from, and those are the coordinates in UTM. So if I want to store those UTM coordinates in a WebGL buffer as floating point numbers, I will have to drop some digits. I can only store 4.8 digits. I'm going to round that up to 5 digits. Some precision is going to be shaded around, so I cannot store the precise precision. This is not accuracy, this is precision, which precision and accuracy in different terms. I will be dropping at least 10 meters of precision from the longitude and at least 100 meters of precision from the latitude. No, I'm dropping 5 and 50. I'm dropping half of it because I'm rounding up things. Anyway, it's bad. How can we work around this? False easting and false northing. This is the wonderful, crazy idea you have to keep in mind. Instead of just storing the original coordinates, you create a different coordinate reference system, which is the same reference system that you're using, but with a different easting and northing, or false easting and false northing. And in this case, I can say, hey, my false UTM 21 south is going to have a false northing of 300,000 and a false easting, no, the other way around, a false easting of 300,000 and a false northing of 6.1 million. And in that case, the numbers I have to store can fit within the precision limit, and I can work with this. I will try and show this really fast here. This is an example with, this is the 2 example. Come on, this is the offset example. I'm just storing things around this number, which is the magic crossing point of the precision limit. So if I do not do any fixes, this is how it will work. The data starts to clamp together, and things start to not work as you expect, and the polygons start to look jaggy, and things are not good. This is how it should like. Every pixel should have the same difference between them. This is how it starts to look like. Things clamp together. Your arithmetic starts to round up in weird ways, and your map display is wrong, and that's a problem. Okay, so going on. The thing with tiled data and why tiled vector data works wonderfully with WebGL frameworks is because tile corner is an implicit false or nothing. So all the coordinates within a tile, a vector tile, are relative to the tile, not absolute to the CRS. That's why it's way easier to do this, and that's why I have to go a bit around the walked path to find a solution to non-tile data. Also, when you move the map away from the center of the CRS, you have to recalculate everything. This is easy if all your CRS data is in specific buffers, so you need only to change the buffers with the CRS, applying the offset, or recalculate it together if you're doing a full projection. But the point here is that whenever you are far too away in terms of longitude, latitude, or zoom level scale, you have to reproject everything into the new false CRS in order for it to look nice, which is the thing I do in my code. Anti-meridian, we all know the anti-meridian as why is my map bad on the border of Russia and Alaska? Why is Russia broken in two? I don't understand why this happens. So the approach to fix this is the leaf that we're thinking, which is there can be coordinates in a CRS outside of the limits of a CRS. I will, however, keep in mind how much I need to wrap coordinates if they fall off the anti-meridian. This is a very simple algorithm. If the first coordinate is further away than the CRS origin, I wrap the coordinate. If the nth coordinate is further away than the n-1th coordinate, I wrap it. I'm going to try and show this. Yes, with this example. This is already being fixed. So this is fixed. I don't want to fix this. I want the coordinate system to not have the, wait, I need to reload. And yes, I want the coordinate system to not wrap the things around. This is my original data. Okay, I have one line from 170 to -170, and one line from 180 to where are you? This is the coastline example. This is my data from 170 to -170, and from 190 to 200. And this is how it looks like if I don't care about dropping anything around. If I do care about dropping things around, I can comment things and reload, and things will start to look like I expect. Still, I will be having this thing here, but it's a minor artifact compared with the problems of having data across the whole map. Also, if I just go to the other file and then comment this trick here, what I do then is every layer, every acetate, every kind of symbol in this map, I will calculate the bounding box for, I think a slide for this. Yes, this is my data example here. So I will calculate the bounding box of this moved translated data, and it will work as we expect. I'm just redrawing everything several times. Programmatically easy to do. And then raster meshes, since we are a bit short on time, I will just say that I did a raster mesh library, and just as before, I will be copying the link, and you will be seeing this link in the past because I'm Ivan from the future. And that's all. Thanks for being awake during this crazy fast talk.
Thank you very much, Ivan, for your talk. We overran a little, but I think we have time for one question at least. This one, for example, have you looked at the new web GPU standard, and do you have any opinions about it?
I haven't looked at it in depth. I am scared that it's repeating the errors of the past in regards to data structures. I should look at it, but I don't have the time to look at it. My priority is rather to look into things that have much wider support in current web browsers at this time. Also, I don't want to go into discussions with the people implementing the web GPU standard because I risk getting really angry with the people who are trying to design it. And there's no benefit for me to spend a lot of time going into the discussions about the web GPU design. So not yet, maybe in the future, but first WebGL 2. I need to understand WebGL2 and all the changes and implement framework around that and try to push this map framework forward, and then I can start thinking about WebGPU. One of my concerns with WebGPU is that I'm not sure how easy or how straightforward is it to dump WebGPU data into a visible frame buffer, i.e. into your screen. WebGPU is, I think, from what I can gather, more oriented at processing data, not displaying data. You put a bunch of binary data into the GPU, you get a bunch of binary data into the GPU, you don't get an image. As far as I am aware, I might be wrong on this. Maybe we have time for another quick question or two?
Yes, I think. We have one. Someone is asking if your WebGL map library or any of the demos are public. I think so. They are in GUI library.
No, this is going to be called Gleo, not Glee. Glee is the library for WebGL abstraction. Gleo is the one for maps, which I haven't released yet. I hope to be able to release it shortly. It's going to be hard GPL. Why is it going to be hard GPL? I don't want to use hard GPL JavaScript libraries. Well, this is my response to Mapbox GL2. I don't want, I am angry at Mapbox GL2 being completely closed source. So my response is, okay, I'm going to just throw a tantrum and license all my stuff as hard GPL, even for JavaScript. So if this decision of mine is not okay with you, I will be happy to let you try and convince me why I should do something different than GPL, as long as it has some benefit for me, which at the moment I don't think it has, or nobody has given me any well put together reason for this.
I see. Well, I'm sure that people can find you in the conference and can discuss it with you.
In the links I pasted in the conference chat, you can find my contact details if you want them. So thank you.
Okay, perfect. Thank you for your talk, Ivan, and we will be seeing you in Phosphor-G. Bye-bye.
Yes, see you soon.
And now we will be setting up the start by Stelios Binalis. It will start in 4 minutes, so see you soon. Hello everyone, this is Phosphor-G 2021 in the Huamahuaca zone, and next we will be having the talk by Stelio Vitalis, CityJSON 3D city models for everyone. And Isa yours. Will you be, no, you are sharing already, sorry. Okay, so go.
Okay, thank you very much. Good evening, everyone. Buenas tardes. So this is a presentation. I'm Celis Vitalis. I am from CDG Information Group of TU Delft, and this is a presentation about 3D city models for everyone. So basically, about CityJSON, how we try to use that to do fun stuff with 3D city models. So let's start with what 3D city models are, actually. So 3D city models are it's probably a bit broken. Can you see my slides? I hope so. So the 3D city models are a way of representing the urban environment with 3D data. You can think of them as some sort of 3D shapefile, although they are more structured. So the main idea is that we standardize certain features, like we have buildings, we have roads, we have vegetation and stuff, right? And there's a standardized way of how to represent these things. But except for this just flat thing, as we normally have in GIS, we also have semantics. So think of a building, right? If you had a 3D shapefile, you would only have like the geography of the building and its attributes, right? But sometimes we want to have more deep hierarchy. So we want to have the information about the individual roofs or the surfaces that are walls and stuff, and we want to have both the type that they are and also sometimes attributes about that. So let's say one wants to store the solar potential of a specific roof slope. So for this specific surface, they could attach certain attributes over there. So this is the main characteristics of 3D city models, therefore, is this semantics, the complex data model they have. So 3D city models can be used in certain applications. You can see some examples here.
Sorry for interrupting you. I'm seeing the slides cut out. I don't know if they are like that or.
No, they are not in me.
Can you try sharing again? Maybe something's coming out of the page. One moment, sorry for the problems.
Let's see now.
Okay, let me try to put them. Okay, can you try changing it just to be sure?
It's still happening.
Yes, I don't know why is that happening. Can you try maybe in window mode? I don't know, maybe it might be a issue with full screen.
Yep. Let's see that. Oh, that's better. Right?
Okay, now it's working perfectly. Okay, perfect.
Awesome. Really sorry about that.
No problem. Okay.
Anyway, so as I was saying, 3D city models, they have this complex data model, etc. And they can be used in certain applications. So here are some examples. You can be used for solar potential estimation, for visibility analysis, 3D cadastres, all the things. For instance, in the Netherlands now, the new environmental legislation really needs to have 3D data because it has a 3D algorithm to compute these things. So you can see some examples there. The last notion about 3D city models that I guess it's better that you know is the notion of LODs. So this is much in the generalization aspect from cartography, I suppose. So depending on the application, you might need different complexity of geometry because we don't always need the most complex geometry for any application. And therefore, we have this notation of LOD 0, 1, 2, and 3. And then that was initially a simplistic way. You can think of the first column that you see over there on the left. But then it was refined to have also the horizontal aspect into consideration. So you can have LOD, for instance, 1.2, which means prismatic objects with enough detail on the horizontal aspect, or you can have LID 1.0, which basically means just some bounding box of some sort. So why am I talking about the CD model for everyone? So we've had CDGML for a long time, and it has been an OGC standard for a while. But the problem with CDGML is that there wasn't too much software support. And for us that were developers and we're working with developing software against it, we many times figured out it's really hard to work with CDGML files. And that's not a problem CDGML per se as a data model, because there are two aspects there. There's the data model. So as I said, all the theory about how you describe objects and how you subdivide them into individual semantic surfaces and stuff. But it was more of the inherited problems that you get from GML encoding. And I think if everyone has ever worked with GML files, they probably understand what I'm talking about. So the idea was like, could we come up with a JSON encoding of the same data model and simplify things? Because with CDGML, quite often we would just develop some piece of software and it would work fine for the most part, but there would be some corner case here and there, and quite often there would be a corner case that would break things. And then we came up with CDJSON, and the focus of that was to make it easier for developers and for users. So you can go to cdjson.org right now, and then you can see everything about CDJSON. And the point is, of course, that we need to have more information. It needs to be more transparent to the user, easier for users to approach. And this is what I'm going to talk about today, mostly like the ecosystem, the software that you can use, and mostly what kind of fun things we can do with 3D models now that we have the tools after all these things. This started 3 years ago by a colleague of mine, Google Edu, and everyone started contributing from the group. And now I think people from different groups and disciplines and companies, they are also contributing to the project, and that's really nice. So what you can find if you go to cdjson.org, you can find some tutorials for users, how to download data, how to visualize them and stuff. You can just go and read about stuff. And if you're a developer, you can also go there. And I think parsing a JSON file is quite straightforward, but you can also go through that and get the specifics on how to work with CDJSON specifically. Of course, there's a lot of CDJSON data. Most of it comes from like CDGML datasets that were released and we just converted to CDJSON, but more and more we see new cities or new organizations just releasing data in CDJSON format. And I think a good example is a project that I presented yesterday, and tomorrow my colleagues Balazs Tukai and Ravi Peters are going to present as well. It's called 3D Bach, and it's 10 million buildings for the whole of the Netherlands. And it has been produced in 3 different LOBs, so like from simple prismatic buildings to more complex roof structures. Yesterday we presented the viewer, and tomorrow there's going to be a presentation about the data itself and the process of reconstructing them. And it is released, among others. It's been released in OBJ, for instance, GeoPackage, but it's also been released in CDJSON. And actually there we saw also the power of this complex structure that I said before, that we can encode these things in a more natural way, I think. So, but what I want to mostly focus about today is the software, right? And if you go to cdjson.org again, there's a menu option for software, and then you can see all the pieces of software that supports CDJSON. As you probably see, it's pretty much all open source, with the exception of FME, probably. So I'm going to start with what we provide, what kind of software we develop for the users to play with, so what you can do. I think the logo might be on top of the links. It's kind of a pity, but I'm going to share the presentation afterwards in the comments anyways. So all the links that are being hidden by the logo, you're going to see them anyways. So the first one is CGIO. CGIO is a Python library and a command line interface. So you can just download, you can just install it if you have Python by using pip. And it's basically the Swiss knife of CDJSON. You just use it from the terminal, and you can split files, you can extract LODs, you can compress, you can merge files, you can do a whole bunch of things. Yeah, but this is more terminal, so or for developers who want to do things with Python. So I wouldn't say it's the most user-friendly, but it's definitely a very feature-rich tool, and it's probably the one where we implement the most things. The second one is a macOS viewer, which is being developed by Ken Arroyo Hori from our group as well. It's not a CDJSON specific viewer. It supports other formats as well, OBJ. It used to support CDGML, but I think CDGML's support is dropping now. It's open source as well. You can find it in the App Store as well, and you can just install it, or you can find it in GitHub. and it's quite fast, and it gives you all the information you want to know. The third one is Ninja, which is a web viewer. It's the official CityJSON viewer. You can just go right now to ninja.cityjson.org and it's there. So as long as you download the CityJSON file, you can just drag and drop it there and you can immediately start navigating around. And the cool thing is you can see both the 3D data and the semantics on the left. And you can start understanding the hierarchies there, like the buildings and what part in the city they exist and all this information. And if we have enough time, I might be able to show you a small demo of that towards the end, depending on how many questions we have. Another one is QGIS plugin that we have developed. It's called CityJSON Loader. You can just find it in the plugins repository of QGIS. If you just open QGIS, you go to plugins, you will search for CityJSON, it's there. And actually, I think this is a very interesting and quite promising thing. It has been developed for like 2.5 years probably, and you can use that to load all the data. The interesting aspect here is that, you know, as I said before, this is a complex data model, and in GIS we have this flat, relational data model, right? So there's always a problem on how to go from one to another. How are you going to have like both buildings and the individual surfaces and stuff? So there's a bunch of options about how you want to load the data, and then unfortunately you often have to have redundancies, or you just have to discard some data. But nevertheless, you can load data and do fun stuff. For instance, you can load 3D bar, let's say LOD2. So you have semantic surfaces and stuff, and then you can split it by surface. So you have the floors, the floor surfaces and the wall surfaces and the roof surfaces as individual features, and then you can filter only the floors, for instance. You can merge these things, and then you can keep only the footprints, just like that, with the attributes of 3D bar. That's one example. Later on, I'm going to give you another hint about some things that we're working for QGIS. There's some basic analysis you can do with QGIS. There's also a 3D view in QGIS since 3.0, which is cool, so you can use that as well. But yeah, not that much that you can do with 3D processing for now, at least. And the last thing that I want to talk from the piece of software that we produce is this Blender plugin, which is called Up3Date. This is basically the outcome of a thesis by a master student, and we also helped a bit to make it faster and stuff, and works quite well, surprisingly. So you can find it in GitHub, you can download it, you can install it in Blender. And if you're in architecture or something, you can just load the 3D city model and maybe load a beam model next to it, or you can edit the individual city model, and you can actually save back the CityJSON model, so you can make individual changes there. And that opens also the possibility of using 3D city models for architecture or even civil engineering or whatever you want. Of course, Blender, QGIS, all of these, they're all open source software as well. So everything is open, you can use that. And on top of that, the plugins themselves. Now, a few examples of what others did with CityJSON. So how the ecosystem seems to be built by others, except for us. There's CityGML for GA and also CityGML Tools, which is a tool based on that. It's a Java library, and it's built by Virtual City System, a company in Germany, and it's open source. You can download to load CityJSON data and convert them to CityGML, etc. And yeah, you can use CityGML tools directly from command line to put pretty much what CityGML is, but for CityGML, to convert to and from CityGML. This, I became aware of that, to be honest, this morning, so I just added it here. For instance, certain toolkits adding support for CityJSON. As far as I'm concerned, this is a toolkit about 30 urban analysis or something like that. But I think it was interesting. It's there. It's open source. There is an open source license, and there's a dual licensing where you can purchase something. But it's still cool that these things exist. This is an extension that has been developed by Belgian PhD candidate. I don't remember the name now. That's not nice of me. I'm sorry about that. But anyway, so CityJSON and CityGML, they have this concept of extensions and ADEs, respectively. So in CityJSON, we call them extensions. So the point is, like, if you are interested in something, let's say energy consumption or something, and you want to standardize that. So let's say if you are interested to how to model energy consumption per building, then you want to say that, for instance, for energy consumption, I'm going to have this and this and this and this value, and the range of these values is supposed to be this, for instance. And then this way you release that as an extension, and then other people can use that extension to know that they should follow the same notation, and they can check whether they are valid against this notation. And this specific extension is about point clouds, how to store point clouds in CityJSON itself. For whatever reason, you might want to do that. Now, a few other work in progress. One of the support for GCP API features, in case you don't know, like WFS 3.0 is supposed to be more agnostic about the content itself. So one of the notions is that we could possibly use CityJSON there. And I think JSON works well with the web. So yeah, we're working with some things here and there. There's some prototypes. There was a student thesis there. But that's still a work in progress there. There's versioning, which is, I'm very excited about that because it's the topic of my PhD, which I'm supposed to finish very soon. And this is basically Git for cities. So it's a way of having, let's say, some kind of a repository where you can have all your versions of city objects, and you can look into their lineage and stuff. And it's not only something that is, something in a piece of paper or something. I've developed also this prototype where you can just find it on GitHub. And you can already play with that, so you can start having versions, branches, and stuff. I'm not saying it's 100% robust. I haven't seen it breaking, but we haven't tested it that extensively. Yeah, the last bit I would like to talk about is applications, because applications are fun. Like, it's fun to have all this tools, it's fun to have all this data, but most of the times we've seen like cities, organizations releasing city models with nice visualization and stuff, and everybody's excited and it's nice and it's cool, or someone just happens to take it somewhere and just do something. But for the most part, it's not really, we don't see them that much utilized, to be honest. So the idea is like, what kind of fun stuff we can do. So this is a piece of research that we started basically a couple of months ago, maybe more than that. But we figured out PyVista and PyMesh, which is two Python libraries. PyVista is based on VTK, and they are very easy to load. It's very easy to load CityJSON data there. Later, you're going to see a repository where you can find some code about how to do that. And you can do a whole bunch of fun stuff. So for instance, here you can see with PyMesh, we can do certain operations like intersections, differences, symmetric differences stuff. For instance, here, you can see how we can use PyMesh to do the operation and PyVista to visualize these things. So on the top left, you see the green outline is the original LOD1. The red outline is the original LOD2 from 3D for one building, and then you see the intersection of these two. So I think it's cool that we can compute these things now. You can do some proximity analysis. You see at the bottom left. You can, at the top right, you see some kind of clustering of surface by normals, which is cool when you have triangulated surfaces and you want to group them together. And we use that to compute, for instance, shared walls between buildings, which is really useful for applications. For instance, we know of some insurance company that was interested into computing stats about these things in order to evaluate the risk of a fire or something. Or you can compute grids, like you can see at the bottom right. And you can compute a whole bunch of stuff. And yeah, we're doing 3D urban analysis based on that. We're computing a whole bunch of stuff like volume, the volume of convex hull, the volume of the object, the oriented bounded box, and a whole bunch of metrics that they're supposed to describe the shapes. You can find this at this repository. It's currently a research undergoing, and we're going to publish that quite soon. But the repository is already public, so you can just take a look at the code and, I don't know, have fun with it as well. You can run it against any CityJSON dataset, and you get all this, like, I think it's about 30 to 40 different metrics and information about data. And we're planning to use that for doing some 3D urban morphology analysis. The other thing, which I think is pretty cool, I started this, to be honest, personally as a side project this summer for fun. Yes, that's how we have fun this summer, apparently, with Corona. So this is a way to incorporate PyVista in QGIS, which isn't that easy because of some issues, especially with macOS and how to install it. But the notion is that you could have, for instance, I don't know if you can see it, but on the top left, you can see an expression. And there's already like two functions there that I was able to quickly add to compute the volume of a geometry or to identify whether it's a solid. And yeah, you can use that, for instance, to for the calculator to add one extra field, or you can use it to do customized conditional formatting or something like that. A bunch of analysis, like for now only a couple, but we can add easily all the metrics that I said before in the processing toolbox, and hopefully soon you will be able to do all the 3D analysis that I said before from inside the QGIS. So thank you. I would be happy to answer any questions. Yeah, and this is my contact details for the most part.
Hi. Thank you very much for your talk, Stelios. It was amazing. And yes, we have some time for Q&A and we have some questions. First one is, do you find CTGML difficult to work with because of the XML encoding, or do you think the model itself is too compressed? For example, supporting too many edge cases.
That's a tricky question. The first obstacle that one finds is the GML problem, right? The data model, yes, can be sometimes very complex. The problem is, but if I want to be honest, I mean, that's happening also to a certain extent with citation. We're trying to figure out eventually how practitioners want to use these things. So we need to experiment more. We need more people to actually work with these things. And I think eventually all these things, they're going to be simplified. So yes, CTGML sometimes can be bloated. I think it has been bloating more and more because we keep adding things theoretically without having people that actually ask for these things and they actually apply these things. But I think it's okay as soon as there is open mind and we can always go forward and adapt.
All right, I'm sure. Well, second question is, are there sorry, are there already best practice approaches in how to compare between CTJSON and CTGML databases?
Sorry, I missed the first part of the question.
Yes, sorry. Are there already best practice approaches in how to compare between CTJSON and CTGML?
Best practice approaches to compare between them. Well, for a database, actually you can use CTGML tools to convert from CTGML to CTJSON files. So that's just files, right? So the databases. The database is another aspect. I didn't touch that, but there's still the CTDB, which is closer to CTGML. And this is one problem that we would like to tackle as well. The TXCDB is also a bit of overcomplicated, to be honest. And we were also trying to find ways to have a more simplified version for that. We had some master thesis, but we don't have an answer for that. But if you want to go from CTGML to CTJSON, you can just download CTGML tools. You can look it up. It's from CTGML4J, the same library. It's Java, so good luck with that. But yeah, it works for the most part. You can convert CTGML to CTJSON. That's what we did as well. And the other way around, of course, if you need.
Okay, thank you very much. And I think we have time for more questions. The next one will be, can you explain better how you publish CTGML data as OGC API features? Maybe I should copy that one.
Well, CTJSON, I suppose, because CTGML, well. So I wasn't, I haven't worked on that much. The point is that, well, with OGC API features, you're supposed to, let's say you have a collection, which is probably before it was just a whole file, and you can just say, give me the first 10 ones, or give me the objects that they have these specific attributes, right? So the point is, I want to be able to just ask for 10 buildings that they have these features, or just like as many buildings that they have these features, and paginate these things. And because this is a JSON snippet, we're supposed to be able to shorten that. So instead of giving you the whole file, we can just select these 10 files, make quickly a CTJSON file, and share that. There are some technical issues with the fact that CTJSON tries to compress some things, and we need to figure this out. But for the most part, this is undertaken for now. We still need to see how this goes with clients and stuff. I hope that was a good explanation enough. If you have any more complex question, I would be happy to discuss this over mail or something.
Sure. We have some time for one last question. Uh, what are the use cases of CityJSON compared to 3D tiles?
Oh, well, that's a good one actually, because yeah, I was supposed to talk about 3D tiles. I didn't find the time to do so eventually. So 3D tiles suffers from the same issue that GIS data suffers. It's super fast, so that's a good thing, but it's flat, and that's where 3D models don't fit, right? So for 3D buff that I said, we work on the viewer and we have the data, CityJSON data, but we wanted to release them fast. If you want to do that, you eventually have to go with something like 3D tiles. But then you have to decide. It's the same as when you import CityJSON data to QGIS. You have to decide that you either discard data. For instance, let's say I only care about the building as a whole, and I don't care about the individual semantic surfaces, therefore I discard this. Or I care about semantic surfaces, which means I need to maybe copy all the attributes of the building for every surface individually, right? So eventually you either have redundancy or you lose some data. But 3D tiles has its own, I think, useful aspect that it can be used for disseminating fast and in the web. And CD is probably not the most appropriate way to do so. It's of an exchange format to download static data.
Okay, I see. Thank you very much. And I think that's time. So thank you very much for your talk, Stelios, and for being here in Phosphor-G.
Thank you very much. Good night, buenas noches.
Good night. And next, well, we will be seeing you in Phosphor-G. And next time will be a half pass with Kijon. So we'll be seeing you soon. Hello, everyone. Welcome to Phosphor-G. Today is Thursday in the Huamahuaca room. And next we will be having Ki-Jong Lee, who will be presenting voice indoors, voice indoor map service for visual impaired persons in the UN. So thank you, Guillaume. You can
All
proceed.
right, thank you. All right, okay, so thank you for the introduction. So I'd like to present our work of the collaboration between our university and the UN OICT, the colleague Susan Shannon and Sung-Soo Son. The topic is Voice Indoor Map for Visually Impaired Person in United Nations. Right. So could you play the first video, Jules?
My name is Suzanne Shanahan, and I am the Chief of the United Nations Enterprise Application Center Americas and an accessibility advocate in the organization. 15% of the world's population, over 1 billion people today, are living with disabilities, and 1 in 4 people will experience a disability in their lifetime. Now, as we face the global COVID-19 pandemic, persons with disabilities are being disproportionately affected around the world. In 2019, the Secretary General launched the Disability Inclusion Strategy to strengthen the system-wide inclusion of persons with disabilities, and we are fully committed to making our information, services, and premises accessible to all. The strategy plays a crucial role in supporting the member states in achieving the 2030 Agenda for Sustainable Development and its central promise to leave no one behind. The strategy also supports the Convention on the Rights of Persons with Disabilities, which celebrates human diversity and human dignity. The main message of the Convention is that persons with disabilities are entitled to the full spectrum of human rights and fundamental freedoms without discrimination. We have learned that one of the key enablers for accessibility is technology. Never has this been more apparent than in the current COVID-19 pandemic reality, where so much of our lives has shifted from the real world to the virtual world, bringing opportunities for technology to change the way we work and collaborate. We also know that innovative technology that is designed for the 15% of the world's population with some form of disability can also be greatly beneficial for the other 85% that will encounter limits to what they would normally be able to do during some part of the day. The time to work on accessibility is now. Organizations are shifting their mindset towards accessibility as a must-have, not a nice-to-have. And this is why we are so grateful to be working with Professor Lee and his team at Pusan University to work together on an open source initiative for voice indoor map services for visually impaired people as part of our wayfinding indoor navigation initiative. More than 1 million people typically visit the UN headquarters in New York every year. It is the home of the General Assembly and countless events and conferences that support the work of the United Nations and serve the world. It is simply critical that this iconic building and the surrounding premises be accessible to all our visitors and staff, and that they can navigate safely and independently and participate fully in our events. The Voice Indoor Map Service pilot aims to allow visually impaired people to use their smartphones for step-by-step voice navigation throughout the UN facilities. This will create a more inclusive experience at the United Nations for visually impaired people, and it will also lay the groundwork for additional accessibility services in the future. For example, voice navigation for those with mobility impairments, such as wheelchair-friendly routes. We chose headquarters in New York to showcase our prototype in this pilot, but we also plan to offer the solution when finalized to all UN locations around the world in support of the UN Disability Inclusion Strategy. Once again, I would like to thank Pusan University, Professor Lee, and his team and mine for their collaboration and contribution to this important work. Thank you.
All right, great. All right. Could you switch to my all right. Then I will go to the technical detail of of VIM that we are presenting here. So VIM is basically a smartphone application for visually impaired person to provide the indoor map service and navigation service. This is basically composed of 3 different components. The first one is indoor navigation, indoor positioning, of course, and indoor map, and indoor voice instruction. So, first of all, before going to the technical detail of these 3 components, I would like to give an overall idea about the system architecture. Our system VIM is composed of 2 different layers. The bottom layer is indoor positioning layer, and the upper layer is a service layer of VIM application on smartphone. The reason that we divided it into 2 layers is the indoor positioning solution are, unfortunately, most of them are proprietary. So we cannot include it into our open source software. So we try to decouple it into 2 different layers, and they communicate via a standard interface. That means IPS provide the information about the current location X, Y, and the height using the Z value or flow number, and with the heading information and timestamp. That after receiving the current location, the VIM application provide a map service and voice instruction services. All right. So this is the floor plan of the United Nations headquarters in New York City that we will provide the proof of concept test scenario. So we have 2 entrances here, and the first scenario is from the entrance to the elevator, which connect to the ground floor, the base 1 floor to this one, and then that had to the meeting room. And for example, another scenario is from the meeting room to the restroom. So we are trying to apply our VIM solution for these 3 different scenarios. All right, so I'd like to explain the technical detail of the 3 components one by one. First of all, of course, indoor positioning system is the most critical one. So we are using hybrid approach with the Wi-Fi signal strength and geomagnetic sensor and beacon and even PDR. So we are combining all these methodology for provide an accurate indoor positioning system. But this is a very difficult one, and the accuracy depends on the site and the environment, such as if we have a parabolic antenna, it may disturb the field of geomagnetic sensor, and actually it gives a degrade of the accuracy anyway. So in order to provide more accurate position, we installed 37 beacons on B1 floor and 79 beacons on first floor, ground floor, like this one. But during the deployment, we have the pandemic situation. So we firstly deployed the beacons 2 years back at the end of 2019, but due to the pandemic situation, the deployment of the site has been delayed and suspended. So during that period, all the batteries are run out. So this is quite a serious challenge for the maintenance anyway. And the second part is indoor map. So the requirement of indoor map is to provide first the information about the indoor cell. The cell means like a room or the restroom or corridor, etc. And we need the geometry of each cell and the utilization or functions of each cell, whether it is a classroom or office room, etc. And we need also the information about the doors and elevator and stairs which connect the 2 different cells. For example, via doors, we connect to cells, and elevator, we connect to different floors. And the next one we need is navigation networks. So of course, it is very critical for path planning. And it includes not only horizontal connection, but also vertical connection to connect the different floors. And the last, POIs, like a landmark and safety POI. In order to satisfy this requirement, we decided to use Indo-GML, which is a Indo spatial standard published by OGC. And this is the workflow, how we use Indo-GML to provide the service. For example, giving the starting point and ending point, we compute the optimal path using the network information of Indo-GML. The optimal path, it is not necessarily shortest path, but also some paths satisfying several constraints for visually impaired person. Then, with an optimal path and the current position data from Indo positioning solution, we can dynamically generate the voice instruction on the fly. So this is the overall the workflow of the VIM application. Then I'd like to give more detailed information about the explanation about the voice instruction. Voice instruction is classified into three categories. The first one is instruction for navigation. That means turn-by-turn instruction. And the second one is POI instruction. And the third one is current location instruction. Sometimes we need the information about where you are exactly. For the first one, the turn-by-turn instruction or navigation instruction, the basic idea is we divide the whole path into segments. And for each segment, we provide three types of instruction. For example, if you are at the starting point of a segment, then we give the starting instruction like go forward 10 meters. And if we are approaching to the end of the segment, then for example, 2 meters ahead, we provide a preparing instruction like stop at 2 meters ahead, so that the user can ready to stop. And if he or she arrived to the point where he should make a turning, then we provide instruction for like stop and turn to 3 o'clock. So this is a normal case. The basic idea is we divide the whole route into a set of segments, and for each segment we provide these three instructions. But sometimes the segment could be too short to include the three instructions. Then we may simplify it to two instruction or even one instruction. And sometimes the user may deviate too much from a given segment, then we provide a correction segment, such as a warning segment and correction segment and restarting segment. And for the POI instruction, this is very simple. For example, if you are here and if you want to provide a POI instruction, then you may give the instruction like POI C at 4 meters to 3 o'clock. That is quite simple. And the final instruction is the information instruction about the current location. That could be dependent on the case. For example, if you are on the way to the end of the segment, then you may give the instruction like 4 meters from B to A. A to B. And if you are exactly on a spot, then you may say that you are at spot C. And the same way, if you are at the intersection point, you may a similar instruction. Okay, and one thing that you have to bear in mind is how to name node and path. This is quite important one. So the first principle is we have to make the name as short as possible, because the time interval is the most precious resource for VIM service. We may not include many instructions for a given interval. So we have to make it as short as possible. And for naming a node, that should be meaningful. Like if you have a precise name like a visiting center entrance or security checkpoint, that could be a name of a node. And naming path, even though it is composed of several different segments, it would be better to aggregate it into one single path, and you may give the name like from visitor center to checkpoint. All right. And we have quite an interesting challenge for voice instruction. That means scheduling issues. Then when we have too many instructions in a given interval, then we should avoid the overlapping between instructions. That means we need a proper scheduling. Proper scheduling means we have to consider the priority, and we have also consider the spatiotemporal validity. Spatiotemporal validity is, for example, if you are here, then you may give an instruction like kiosk is at 10 o'clock, but the user is moving ahead, so the instruction is at some point no longer valid. That means for any instruction, there is a spatiotemporal validity. So we have to consider this spatiotemporal validity for proper scheduling. Right, so I'd like to show the video that we developed. Could you play the second video, please?
Go 23 meter forward. Warning, a revolving door is located at 4 o'clock and 3 steps.
From the entrance of the United Nations building. Sorry.
Go 18 meter forward.
Follow the instruction that he received from the smartphone.
Turn 10 o'clock. Go 6 meter forward. Stop at 3 meter ahead. Turn 3 o'clock. Turn 3 o'clock. Go 41 meter forward.
He is not very familiar with VIM, so he is a little bit confused with the instruction, but
go 33 meter forward.
We have to do is for providing such application, the user should be a little bit.
A portraits of the Secretary Generals is located at 4 o'clock and 0 step. Go 21 meter forward.
And something like that. So after that training, I think
go 12 meter forward. A portraits of the Secretary Generals is located at 3 o'clock and 0 step.
Okay, so because
stop
of the
at 3 meter ahead.
I would like to continue my presentation.
A portraits of the Secretary Generals is located at 4 o'clock and 4 step.
All right, thank you. And right. So this is quite a short example of the demonstration at the site of UN headquarters. All right, so as a summary, I gave a short presentation of voice indoor map service. And we are conducting a pilot proof of concept at UN headquarters. And the source code is available at this GitHub site. It is in Java, and this one is Android version. That means we need to port to iOS. But anyway, this application is quite early stage, and we need housekeeping, and we need some of the work for stabilizing it. That means we need your contribution. So even though we initiate this application, if you can participate to our development and deployment, that would be very appreciated. Okay, thank you.
Thank you very much for your talk, Kiyo. It was The demo was very impressive. We can proceed with the questions now.
Yep.
So, first one, do we need to install any infrastructure for beam other than beacons?
Yeah. So this is the question about the indoor positioning. We need, of course, the beacon if it is possible. So, but for beacon, we need the maintenance issue. That means for every 2 years, for example, we have to change the battery and we have to regularly check whether some beacons are dead or not. This is a maintenance issue. And the second one is for if you have a quite a dangerous area that we have to care about, then we need a little bit more additional, for example, device which give the arm warning message to user. For example, at the UN site, if you have been there, so you may find several bank of elevators. The first bank is to lower floors, and the second one is high floors. But the distance between the bank one and bank two is not sufficiently far away. That is a little bit of 5 meters, but 5 meters sometimes it is difficult to keep the accuracy on the 5 meters by some IPS indoor positioning. Then we need some additional things to provide more accurate the positional data. So that is something that we need as an infrastructure. Okay.
Okay, thank you.
Mm-hmm.
The next question will be, beam is actually for visually impaired persons. Is there any plan to extend it to other types of impairment?
Yep. So the Susan at the beginning of the presentation, she explained a little bit our big picture. So the first one is, of course, after the proof of concept at the UN headquarters floor, the ground floor and B1 floor, if it would be successful, then we will apply it to the whole UN building. And then the UN has a lot of places in the world like Geneva or Entebbe. We may apply the same thing to each place of the United Nations. And then, of course, as you mentioned, for example, the person of a wheelchair, the person of reduced mobility, we may develop different type of the navigation service for indoor. So this is basically our plan. But anyway, we have to finish our development for the first step. This is very important mission so far. All right.
Okay, thank you very much. The last question we have is, the accuracy of indoor positioning may affect the quality of the service. What is the requirement of accuracy for being service for visually impaired persons?
Yep. That is also very interesting question. So the visually impaired person, they move sometimes with the guide dog or the cane. So they have some device to detect. They help the user to navigate in the indoor space. But so the VIM is a kind of additional solution for the navigation that provide the information about the turning and the POI. So if you don't have any very dangerous location, like just next, if you have stairs, then that would be very dangerous. So considering this kind of danger, we have to carefully design the accuracy of the indoor positioning. If you don't have such kind of danger, then the sufficient indoor accuracy, maybe position accuracy, maybe like 3 or 5 meters. 3 meters would be okay. But if for some special case like that I explained, for the elevator bank case or a danger place, then we need to improve the positioning accuracy of indoor space. So that is, and the technology of indoor positioning is very rapidly developing. So, for example, we are in the near future we may have a solution for 5G. That would be a very promising approach, and also ultra wideband, which is also very interesting approach for indoor positioning. So, if we may have that kind of solution, we dramatically improve the accuracy of indoor positioning, then that would be very sufficient, I think. All right.
All right. Thank you very much.
Mhm.
We have run out of time, so I think that we will have to end here. Thank you very much for your talk and coming to Fast4G and presenting it.
All right. Hi.
Bye bye. We will be seeing you
Bye.
around. Bye bye. All right, and the next talk by Lorenzo and Natalie, Map Store Agile in Review, will start in 5 minutes. See you soon. All right.
Hi.
Hello. You. Well, I will be presenting the talk and we can start right away.
Okay.
So, hello everyone. This is Phosphor G 2021. Today is Thursday in the Huamahuaca room. And next we will be having Lorenzo Natali with his talk Map Store, a year in review. So thank you, Lorenzo. All yours.
Okay. Thank you. Good afternoon. I'm Lorenzo Natali, and thank you for having me. And I work for Solutions. That is a company that provides support for development in various open source products in GIS. We support development of various open source from the core, and we actively participate on OGC or creating new standards for the future. This talk is about MapStore. I will explain what it is for those who doesn't know, and then I will talk about what we did in the last years and what we are going to do in the next future. First of all, let's start from the beginning. What is MapStore? MapStore, it's a product, it's an application that you can, WebGIS application that you can download, customize and install on your servers and run from your, to create your application. Or you can also run them in your personal computer. There is a binary package for that. Anyway, MapStore is mainly a framework that allows to develop a WebGIS application. You can build your own application by creating a new MapStore project using some, all, or none of the base MapStore components that are called plugins. Depending on the level of customization, your final application may look very similar to the standard product or completely different. You can even decide which part to keep, if you want to keep the backend or the front-end library for mapping functionalities only, and put it inside your application, for instance, if you have a completely different backend infrastructure. And what are the functionalities of MapStore? MapStore product itself, it's a sort of a content management system for GIS data with a lot of advanced tool for mappings. It allows to share many different kind of contents with the GIS flavor. With the other users. You can create various contents like maps, dashboards, and now just stories and application contents. This content can be published to be public or to be reserved to the for the access to a particular group of users. As an administrator, you can manage the users of the application, create a group of users, and assign them the access to some of them of these contents. You can also allow to or deny users to create their own contents to share. The user system can be also synchronized with your server to having a single application that publish data for both on the backend and the front end with the same access management system and the same users and roles recognized by the application. The map viewer, that's responsible of the map contents, to display the map contents, has a lot of tools that you can use to customize the user experience. So a lot of plugins. You can travel in time when you have data with the timeline with temporal dimension. You can add to the map some charts, tables, text floating on the map with the widgets. Then you can customize the geocoding service to add your own. You can add annotations to your map and then with polygon markers and so on. So a big set of tools. And the map viewer is accessible also for mobile with a dedicated layout and a dedicated set of the tools for that particular screen sizes. MapStore works with multiple mapping engines. Actually, it uses OpenLayers, Leaflet, Cesium at on its and it's ready for new implementation for upcoming libraries. Other than maps, you can also share dashboards that are sets of maps, tables, and other contents that you can combine and make interactive. Make interact each other. For instance, you can zoom in and out the map and see the charts changing, and the charts is changing, filtering the data by viewport or other things. Other good things, and you can build them by editing simply them on the UI. In the latest release, we introduced also GeoStories that are good-looking pages that you can scroll down and display tell a story with interactive contents, videos, and other media or text, and with good animations and look and feel. And we introduced also application contents in the latest release that allow you to create custom map viewers with a custom set of tools, so you can customize the plugin to show in a particular map to having different viewers with a minimal set of tools or tools of a set of complex tools. Anyway, we will talk about them later in the news section. And we'll talk about them better in the next session. From the last presentation at FOSS4G, we 2 years has passed. MapStore has grown a lot with 4 major releases counting a lot of new features. All these features that you can see here are available in the current release. GeoStory, application contest, Visual Story Editor, all these are already available in the downloadable version of MapStore. Let's go in order. In the last release of 2019, you will be able to filter layers and save filter inside the layers from the moment you save the filter inside the layer, every tool is linked to this layer, and the map too will use this layer as it is filtered originally. So it's a sort of virtual layer that filters the data for the map and all the widget linked to that. From the layer, you can also turn this filter on and off. Regarding the timeline tool, that is a plugin that allows to manage the layers with time dimension, we added a new button in timeline that allows you to show only the points in time actually visible in the current viewport. For instance, here is without the filter applied. You can see statistics of many points that are related to the wall layer, that is a world sides layer. And in this picture, you can see only activating the tool. You can see only the temporal values that are associated to the points in the current viewport. So you can ignore the rest of the map. It's particularly useful when you have a layer with a lot of data and you are interested only on a particular zone. Then, in the first release of 2020, we introduced the possibility to add backgrounds from any kind of source. So now you can add the background of the map from this button plus here and browse the catalog we already have for the layers, also to add the background layers as background. So you can add them from WMS, WMTS, TMS, WFS. Each service that is supported by MapStore is supported also for backgrounds, and you can customize the thumbnail, the title to show, and other options depending on the type. And the first release of the 2020, we concentrated also to update React.js. That is more developer more I think for developers, but anyway, it improved the functionalities and stability and performance in general. In the second part of 2020, we also added the Just Stories, the new type of content that I anticipated before. As I said, Just Story is a new type of content that you can use to share, to create immersive scrollable page with some text, multimedia like videos or images, interactive maps, and so on. You can with the story editor, you can select a color theme to use in your page. You can decide what you can customize every part of the page, like the sides and the backgrounds and of each area and each text or each map. Use the maps as background or as main content. You can do many. You have many possibilities in terms of customization of these pages. Then another important feature in the release of 2020 and the second part of 2020 is the introduction of the application contexts. The application contexts allows the administrator to create alternative map viewers from a new context manager available in the administrator menu. They can be composed to selecting the initial map with the backgrounds, initial layers, and position. Then you can select the plugins you want to get in, and you can configure each of them. And then you can save them. In this example, for instance, we created a minimal viewer with only the annotation tool and the optional background selector that can be triggered by the user if you want to see it. But by default, this map only allow the user to browse the image, the map, and do annotation on that. The context you create as an administrator can be shared with the URL to the final users, so you can create an application only sharing this URL with your users, or you can also use them as a base to create new maps. Maps created with this context will bring the contexts in, so as well as you share so you can create maps in the context and then share them as usual, and the user will see the map not with the default viewer, but with the custom viewer with the tools that you decided to include in that particular map. So basically, this application context system allows to create multiple applications with a subset of plugins that can be can be shared with the users of the portal. Notice that you can add also custom plugins to in your projects developed for your own use case. So this opens the door to a lot of possibilities in terms of creating portals. So for instance, you can create a context for a set of user with a minimal set of tools. Another context reserved to some more technical users that has the tools and the permission, for instance, of editing features, and another last context for the Office team with some custom tools designed for their work. For instance, if they have to enter some particular forms and so on, they can do it using that particular context, and that works like a separated application. The possibilities are a lot and can be adapted to a big set of use cases. In the most recent release this year, it was full of features. So also this release was full of features. We introduced the visual style editor. MapStore already had the style editor, textual style editor that allowed to edit CSS and SLD. From this version, you have visual tools to edit styles for maps, for polygons, and in general for vector layers. You can add text style, you can determine the scale denominator for each rule to create a set of rules and so a set of styles that scales with the scale of the map. And moreover, you can configure to use patterns, icons, or create classification and color ramps inspecting the real data and automatically generated the intervals for the colors and the color ramp itself. We also changed the charting library for widgets. With the introduction of Plotly.js, we improved a lot the charts. First of all, they are more interactive. Then with this change, we were able to introduce time series. So if you have temporal data, you can use time series. You can create charts of time series if you have some vector layer, for instance, with a date time attribute. And moreover, with this update, we did a lot of advanced options to change the number formatting, using a formula to pre-process the results, or customizing the general appearance of the chart. And the annotation tool in this release has been completely redesigned. Now it's very intuitive and powerful. You can you can edit annotations in seconds, having a lot of tools at the same view. So it's very compact and complete. Another tool introducing is the compare tool that allows to swipe the map to hide one layer, hide and show one layer and compare with the background. You can do it with the swipe, so a vertical or an horizontal line that displays the layer only on one side. And or using the spyglass, so you have a circular area where the layer is visible and the rest of the part is not visible, so you can inspect data also in this way. We also in this release we added also the extension system that allows to install the extensions are let me rephrase. We introduced in this release also the extension system. Extensions are plugins that can be installed on the fly in a running instance of MapStore. It means that you don't have to create a custom project, but use the standard one, or use a project and install also extension is also possible. In the wizard dedicated to the creation of application context, you can find a user interface to drag and drop this extension developed by you or by someone that can develop things for you. And so they can be installed in the environment and used in some application contexts. So if you are using MapStore or a derived product that includes extension, you can customize your installation and add plugins without needing to create a custom project, and maintaining only your extension without too much effort for you. What's going on with the future of the releases of MapStore? In the next release that is near to exit, should be out in October. We want to add the possibility to customize the theme of the application context. So these custom applications, this custom map viewer will have also the possibility to customize the theme, and so you can edit the color of the buttons or the inputs of the menus. And we reviewed also the theme system with these changes. And if you develop a custom project, it's easier to change the theme with a few lines of CSS using CSS variables that are now compatible with most of the all the most popular browsers. We will add we are going to add to GeoStories also another kind of section other than the others, that is called carousel, and it's a sort of gallery that shows you some particular points on the map and the associated media and text content, and you can click on the various gallery entries to zoom to that particular place and see the information related to them. And in this release that is coming in October, we will have also the visual style editor for raster layers. So you will be able to edit the styles, raster styles for creating classifications or doing context, doing some operation of the images like contrast enhancement and so on, using the visual tool as you can do it as you can do with vector layers. We did also a lot of various optimization in libraries, reducing the bundle size and the initial page load, and also the requirement for the memory to build. There are many other improvements that we don't have time to discuss. Anyway, for the future projects, for the future release in the next year, we planned to create a new project system that allow you to have a single entry point to create a project and extensions with the same command line tool with a reduced boilerplate that allow you to maintain better the project. Okay. And then we want to support 3D tiles and improve the performances. The time is over, I think.
Yeah, I'm sorry.
Okay.
We will have to be ending now.
Yes. Anyway, just a second. MapStore is used by GeoStore and by Geo Orchestra, that are two famous open source products, and by many private companies and municipalities all around the world. And this is only a small list of the users that we help to install MapStore. And for MapStore, there is the online demo at mapstore.geosolution.com and the user documentation at mapstore.readdocs.io. I was not fast for finalize my presentation.
No problems.
Okay, thank you.
Can you paste me both resources if you have? Or let me paste them on the chat, maybe. At least the demo.
Sorry? Yes, I can paste them.
Don't worry, I
Okay, thank you.
I hope that I didn't mistype. Well, and I think that we don't have time for questions either. So I'm sorry. Thank you very much, Lorenzo, for your talk.
Okay, thank you.
We will be seeing you around in Fosfoye, right?
Yes, I think you will. I will go to the social gathering
To
after
the dinner
this.
party tonight. Okay, we'll see you around. Okay,
Okay.
bye-bye.
Bye-bye, thank you.
Now we will be testing the last string of the day with Andrea. And it will be starting 29 minutes, 3 minutes from now. So I don't know if Andrea is around. Yes. Let's do a quick sound test. Hi.
Hi. Okay.
Okay, I can
Hello.
hear you perfectly. Can you try sharing your slides?
Yeah, sure. Share, and that would be it.
Let me see. Okay, can you try change? Okay, it seems like it's going fine. All right.
Yeah.
I will be introducing you then in 3 minutes, 29, okay? And then we can
Okay.
start.
Perfect.
See
Thank you very much.
you soon. Hello everyone. This is the first 4G. We are today in Thursday in the Huamahuaca room, and we will be having now the last talk from of the day with Andrea Antonello, who will be presenting integrated modeling with KLab. Thank you, Andrea. Is that yours?
Okay, thank you very much. Thanks to everyone who had still the energy to come to the last talk of the day. And I'll be introducing you to, well, at least I'll try to introduce you to the world of integrated modeling with KLab. And today I'm wearing the hat, or I'm talking as a member of a project called AREAS, which stands for Artificial Intelligence for Environment and Sustainability. To better get an idea where I'm coming from, I'd like to go back kind of 20 years, because that's the time when I started to do environmental modeling. And at that time, I was working at a university department, and together with the professor, we were always discussing what would be the best tool to do integrated modeling. And we were working on geomorphology, hydrology, and we're dreaming about connecting models with other models like groundwater or meteorological model, evapotranspiration, or kind of just describe the whole environment, right? And in the end, we came to the point where we said, okay, as you might guess, that tool has to be a GIS, because at least, we're talking 20 years ago, at least that tool would harmonize the spatial context, which is not cheap. So I spent kind of the 20 years after that, up to now, my whole professional life trying to integrate. So if you look at the timeline, you will see different GIS, different modeling frameworks, so like OpenMI, OMS, or the GIS. I not just me, but me and my colleagues, we're trying to integrate with other tools in which we could share models together. So the dream was kind of like to be able like sharing deals model like we did back then when we were kids with stickers. I have a sticker double, so I give you mine, you have one triple, you give me yours, and trying to reach all together the same full set of stickers. And that would be right now like being able to share models. And with the FAIR principles and with free and open source software, this should just be possible, right? Actually, it's a bit difficult, and I can tell you in the last 20 years, I've seen that a lot, because modeling is something particular. You have your project, you do some model that does some strange stuff nobody understands, but it might save the world. So what is the common practice? The modeler takes a core algorithm, which is, let's say, 10% of what will in the end be there, and it then decides, oh, I have to read a raster, yes, and a vector, and I have to read I don't know, rainfall data, discharge data, online services. And so this is a whole boilerplate of IO. And then, well, the results have to be visualized clearly. So then there is visualization code. And finally, there is also a timeline to follow, because my model does simulate the timeline. So inside the model, you have static parts and the dynamic parts. And so you start putting in tricks to make it work along the timeline. And in the end, you end up with a nice monolithic stuff that really works really good. And you can publish, and that's very cool. But it works just for those cases where the end result counts. So if instead you just want to share and connect model, because in that case, extracting what was the core algorithm is extremely difficult. And so it's very difficult to join models from different sources. So how is KLab different, and how is it supposed to help you? Well, KLab forces you to just create the smallest possible entities, quantums of knowledge that just incarnate and represent a concept. And KLab then gives you a resolver that takes all these quanta of knowledge and makes them compete to best explain the requested observation. And all of that is then assembled into a data flow that will contain the best possible strategy to get to the result. Well, I don't know if you were following me. What does that even mean? Let's take it a step at a time. First, I would like to tell you what AREAS is and how KLab got born. we are dating back in 2007, so it's quite some time, when Professor Ferdinando Villa, the visionary and developer, still yet the main developer of Caleb, started a project with a fund of the National Science Foundation at the University of Vermont. Throughout the years, several players contributed and funded the project, and in around 2012, Professor Villa decided to move back, since he's an Italian, back to Europe, and he ended up being at the Basque Center for Climate Change. And that's right now kind of the headquarters of ARES and Caleb. But ARES is not just a project, it's a network of scientists. And this is the breaking point that in 20 years I've never seen before. What I've seen in ARES is a lot of scientists that collect data, that collect models, and that put them in a network, which is what is called the integrated modeling network. And in there, in what we will see is Caleb models, data sets, and whatever processing power is set and made available to whoever wants to enter and model with it. You know what ARES is now, and what's Caleb? Caleb is just a software, kind of a big software. It's a full stack solution that helps modeler to do integrated modeling. So it supports production, curating, linking, deployment of scientific artifacts. That could be data sets and models. And it's just a system to observe the world, the whole world. So not just your little piece of watershed you want to analyze, but it wants to observe the whole world, and it wants to build and extend the world. So I hope behind of some of the screens that are listening now, there is someone who's saying, yeah, hell, where are my ontologies? You can't do this without ontologies. You can't describe a world without ontologies, because you need validation. And yes, you're right, because ontologies are really a necessary ugliness. I've hated them for long. I've never made them enough. And therefore, I love Caleb, because in Caleb, what happens is that ontologies are buried under a semantic layer of a near natural language. What does that mean? That a user can just approach, ask a question in English, and the system will resolve the query into a data flow. And throughout this resolution, it will go down the tree of the concepts and the dependencies of the concepts until it gets down to the ontologies, where it validates everything. So what happens in the Caleb platform is that whatever is produced is also validated. But let's have a look what the platform looks like. There are 5 components, and 3 are server components, the engine, the nodes, and the hub, and 2 client components, Explorer and Modeler. The engine is kind of the heart of the platform. It takes care of the resolution of the whole reasoning to convert the user query into that particular data flow that can be executed and then gives a result. The nodes instead are components, server components that are distributed and that contain the knowledge, scientific knowledge, that any partner can set up a node and can put knowledge in it, being it resources like data or equations, or semantic layer, which is where resources get coupled with concepts, which means they are semantically annotated, and this is where everything gets its meaning. So it's no longer just a resource, it's something that has a meaning and that can concur in the resolution process. And then there is the reactivity layer, where, well, things get to life, really, because you can attach behavior to scientific artifacts and create simulations. The hub is basically an authentication server that organizes the nodes. Very important, we'll see later why, is that it manages certificates, and with those certificates you are part of groups, and you can access a worldview. But that later. So Explorer and Modeler, one is a web application that allows end users to just ask the particular question we were talking about, and the Modeler is something more advanced, where modelers can just develop models, and publish resources. Something like this. This is an editor where you can load a resource in, being a shapefile, a TIFF, or something, even a WCS server or a WMS server. And then here you can add the documentation, license, time, space of validity, and you can publish it to a node. So how can you do to try that out? Well, you need two things. One is the control center that you can get at this link of the Getting Started in the Integrated Modeling webpage. And you need a certificate to access the Integrated Modeling Partnership Network, because otherwise you won't have a world with which you can model. So this is how the control center looks like. You can start a local engine that you can locally use on your computer, and you can start a modeler. And from there, you can finally open the Explorer, which looks like this. This assume if this is an application, an installation, end users would just see this or a customized version of this. The modeler is just used for the modeler application is just used for modelers to develop stuff. So let's have a look how this works. You can start writing your question. I don't know. You want what do you want to observe? Like elevation. You start writing ele, and the system gives you some hint of possible observations that are available, like events, election, or qualities like elevation. And if you continue writing or select elevation, for example, what happens, the resolution process pulls out the resources that best represent the observation. In that case, a digital elevation model, clearly. But you can also enhance it a little, and you can say like elevation, minor or major. You can add some simple arithmetic operators, and which would result in a map with just elevation major than 1000. You can also use semantics operators, which are keywords or group of keywords that have the ability to transform concepts into different concepts, like distance of city, which generates in a map that, a raster map that has in every point the distance from the nearest city. And interesting is that there is a main concept that is observed, but every observation that is generated during the resolution process and the data flow execution is added as a secondary output. As you can see in the lower part, I don't know if this is visible, in the lower part, the 3 cities that were in the current scope, in the current context, are also listed. Everything can be downloaded as shapefiles as TIFFs. Let's have a look at another, like present of mountain peaks. And that will pull all the mountain peaks that are available. But you can do also something a bit more complex, like I want to see the land cover type, but without water bodies. And in that case, you can see there is a map of land cover type, but the water bodies are being left out. There is a moment in which the Explorer comes to its limit, and you need something bigger, and that's where the modeler comes into the game, which is this. And I want just to spend a second about what you can also see in the modeler, which is the worldview. The worldview is basically everything you need, every word you need to be able to model your own models. So if we're talking about a region, who did describe a region? It was described by a community who carefully designed this worldview, and a region anything needs to be described. So for example, a region is an aerial location. And if you click on it in the modeler, you will be led to, for example, aerial. And it boils down, every concept needs to be described. And in the end, at some point, you come, for example, like aerial, you come to the point where you see written, concept is core observation. And this core observation is where Caleb connects to the ontology. This means the ontology is then get from the beautiful old files, and the validation is done by Caleb. So this is the beautiful thing of Caleb. You can use a natural language, but then someone else did for you the whole stuff for linking it to ontologies and activating validation. So let's get back to the fun stuff. Well, with the modeler, you can write more complex stuff. You can just use the model keyword. And if you want to look to observe a different thing like level of elevation, which then gets a new quality, a new concept, then you can say model the level of elevation, observing clearly the elevation, but using as a lookup table the elevation divided in certain classes. And when you write that down and you execute it, you will get a map that is classified following your particular table. And if you want to observe just a particular region, you can use this observe keyword and define a region with a particular resolution or projection. And when you run that again, it will just concentrate on that region. We were talking about the FAIR principle, so we should find and understand how everything happens. And here in the tab above the elevation level map, there are other tabs that you can click and where you can have a look at the data and the data flow. So every time you run a model, it is possible to check which data sets have been used for the resolution. So in that case, it was a simple elevation model. So it's an SRTM on global scale. You see also the coverage of the data set. And you can look at the data flow also. And the data flow, which in this case is very simple, it tells you that it was pulling a WCS resource to take the elevation. And then it applied the lookup table. And if you click on the lookup table on the right side, you will see what the lookup table was. So we're talking global. So what about data harmonization? Because it's a mess when you want to model the whole world, because most of the data sets are not global. So what happens at borders? One good example is the land cover type. If you do it in this area, you will notice that there are more data sets involved. And if you look at the tab with the data sets, you see that it's Korean and it's an ESA Climate Change Initiative land cover. And if you look at the data flow, well, it's interesting because it will tell you that it had to merge different resources, but these resources are with a different classification. So how can this be done? So you click on the classify part of both flows, and you will notice that the different classes have been decoded to the right internal attribute. And where are these attributes? Well, these attributes are in the worldview clearly, because somewhere they have been defined, and KLab will just talk the right class out of it. So what about time? We have processes that can define operations in time. One example is the weather process that is able to create observations of rainfall, temperature, and as you can see, minimum temperature. There is no such thing like a minimum temperature as a single word. No, it's a minimum temperature, like you would speak it out. So this is how it looks like, and you will have a dynamic version of the map that you can then scroll through. But the real important thing is that these maps, these processes, can be then used inside of more complex models. In this case, for example, this is a hydrological model, an infiltration model, for example, or a base flow model. You can see here runoff, evapotranspiration. They all depend on each other. And you can just concentrate in writing the part that defines the runoff, the evapotranspiration. You don't have to care about the water volume, the rainfall volume, about curve number, the crop coefficient. These are all things that come from models already existing in the network. And the result is that when you run such a model, it will generate in the data flow a huge data flow where you connect to the different services in the end, to the resources, or to models that generate. For example, a stream network is created by creating a flow directions map, then a contributing area, then you extract a network, and so on. And everything, whenever you run this model, is run into a flow to give you the result. For example, also, if you don't have a map of crop coefficients, then you could have this tiny little model that you can define in place. You model the crop coefficient observing an NDVI, a normalized difference vegetation index, and you set it to that particular thing. It's just a simple equation. So if there is no crop coefficients map, but this model has been published into your network, it will just use that one. The resolution process will decide which resources it's better to pull for that particular use case. So I think I'm done, and I should be more or less in time. So I leave you with two more slides. One for developers, because you will ask yourself, where is the source code for all this? There's an umbrella organization on Bitbucket called Integrated Modeling, and it contains kind of everything. We should be having a mirror on GitHub also. So, well, we'll keep you updated on that. But you find everything, the engine, the modeler, you find a bunch of examples, and most important, you find a worldview, because the worldview is, in my opinion, the most difficult thing to do in all this. So thanks for being here. If you're interested, since this presentation didn't even scratch the surface of what Caleb is able to do, it has been adapted for a more GIS audience, because that's more or less my expertise. Please have a look at the presentation of the areas for Sea Explorer at the UN, because there has been a huge launch of this application for capital accounting. So please have a look at that, where Ferdinando Villa really explain you the whole nice candies that are behind Caleb. If you want to collaborate, just get in touch at the link you see down there. Thank you very much for being here.
Hi, Andrea, and thank you very much for your talk. I was really impressed by Caleb, to be honest.
Thank you. Good.
And we have some time for Q&A. Our first question is this one. How is the documentation? A college discovered and got excited about K-Lab, but when I looked I couldn't find much documentation for the KIM language.
Okay, that's right. The good thing is that the collaboration with the UN launched a whole forced kind of a whole documentation process. So I missed to put the link in it, and I'm very sorry about that. But there is already some documentation online, and I will, I don't know exactly how to get it right now, but I will post it maybe on Twitter, where you can get a whole idea about what Caleb is and how the technical details also about KIM. I have to admit that the best way to learn KIM is with the examples project. I placed the source code in, because in there are examples and test cases that explain exactly how to write particular situations. I would honestly, that's how I did it. I started from the examples, and since it's quite a natural language, you get, for simple things, you get very quickly up and running.
Thank you very much. I was just posting your Twitter handle in the chat so people can contact you if they want.
Thank you very much.
Let's see, there are no more questions. We can wait a little bit or call it here. Let's give it a few seconds because there is a lot of delay in the stream.
Oh, okay.
Well, seems like there are no more questions, so we can end here maybe. Thank you very much, Andrea, for your talk.
Perfect. It's been a pleasure for me. Have a nice evening.
Thank you.
Maybe I see you at the gala dinner in a couple of minutes.
Yes, I hope. See you then.
Okay. Bye.
Bye-bye. And this is the end of Saturday in Huamahuaca's room. And the last session for today, I believe that there are no keynotes today. So be sure to check in the social gathering, the dining party that we will be having just next after we finish the sessions. And that's all for today. I want to I want to use this chance to thanks for G for the opportunity. I was very nervous yesterday when I started leading Aconcagua Room, but I'm glad I went really fine and it has been very exciting. And I will be seeing you everyone as another people tomorrow. Have a nice evening, everyone, and goodbye.